Many organizations already measure emissions but still struggle to decide what to do next. A decarbonization roadmap transforms emissions data into concrete reduction initiatives, timelines, responsibilities, and investment decisions. The goal is to move from carbon accounting toward a realistic implementation plan that converts climate targets into operational action across Scope 1, Scope 2, and Scope 3 emissions. A carbon footprint tells organizations where emissions are generated, but a roadmap explains what to do about them, in what order, and with what resources. Many companies publish emissions data and net zero targets, but fail to connect them through a credible implementation plan. A strong roadmap identifies specific initiatives, assigns ownership, evaluates feasibility, and sequences actions over time. Without a roadmap, organizations often pursue isolated climate initiatives without clear prioritization or business logic. They may install efficient lighting, purchase offsets, or launch supplier surveys without understanding whether those actions address the largest emission sources. A structured roadmap creates alignment between climate goals, operational reality, budgets, and implementation priorities. Many companies struggle because their reduction plans are too generic. They fail to distinguish between operational emissions, purchased electricity, and value chain emissions. Other organizations create ambitious plans without checking technical feasibility, budget availability, or operational constraints. In many cases, sustainability teams build the roadmap alone without involving operations, procurement, finance, or engineering teams. The roadmap must start with a reliable emissions baseline. Organizations need visibility by scope, site, activity, category, or supplier to identify where emissions are concentrated. This baseline helps distinguish between quick wins and long-term structural decarbonization challenges. Without a credible baseline, prioritization becomes subjective and weak. One of the most important design decisions is separating the roadmap by Scope 1, Scope 2, and Scope 3 emissions. These scopes require different reduction levers, different internal owners, and different timelines. Scope 1 focuses on operational assets, Scope 2 on purchased energy, and Scope 3 on suppliers, products, and value chain transformation. Scope 1, decarbonization, usually focuses on direct operational emissions, such as fuel combustion, industrial processes, and company-owned vehicles. Common initiatives include energy efficiency, electrification, fuel switching, process redesign, and equipment upgrades. These projects often require collaboration between sustainability, operations, engineering, maintenance, and finance teams. Organizations prioritize Scope 1 initiatives by comparing emissions, reduction potential, investment requirements, operational disruption, and implementation timelines. Some projects are low-cost, quick wins, while others require large capital investments and long-term planning. The objective is to sequence initiatives realistically instead of trying to implement everything at once. Scope 2 decarbonization combines energy efficiency with renewable electricity sourcing. Organizations first reduce electricity consumption and then improve the emissions profile of the energy they purchase through renewable contracts, renewable certificates, or power purchase agreements. Procurement and energy management teams play a central role in these decisions. Scope 3 is usually the largest decarbonization challenge because it includes suppliers, purchased goods, logistics, product use, and other value chain emissions. Organizations cannot solve Scope 3 through internal operational changes alone. Procurement, product design, and commercial teams must work together with suppliers to reduce emissions across the value chain. Most organizations start Scope 3 management by focusing on Category 1, purchased goods and services. Procurement teams identify which suppliers, products, and categories generate the largest emissions. Over time, organizations improve supplier data quality, develop product-level emission factors, and collaborate with suppliers on shared decarbonization initiatives. Many companies initially use spend-based emission factors because supplier-specific data is unavailable. However, a mature roadmap gradually improves measurement accuracy while simultaneously working with suppliers to reduce real emissions. Better data alone is not enough. Organizations also need operational supplier action to create measurable climate impact. Once all Scope 1, Scope 2 and Scope 3 initiatives are identified. Organizations compare them using common criteria such as emissions reduction potential, cost and payback period, technical feasibility, and third-party dependency. Many companies use marginal abatement cost curves to visualize which initiatives deliver the greatest impact at the lowest cost. Consider a practical automotive example. A manufacturer identified purchased steel as one of its largest Scope 3 emission sources. Procurement collaborated with the steel supplier to shift from traditional blast furnace steel toward recycled steel, produced through electric arc furnace technology. This reduced the steel emission factor dramatically and avoided nearly 50,000 tons of CO2e annually. Mature decarbonization roadmaps clearly separate actions by scope, assign ownership, include timelines and investment logic, and involve cross-functional collaboration across the organization. Most importantly, the roadmap becomes a real decision-making tool that guides implementation over time instead of remaining a static sustainability document. Organizations that build roadmaps this way are the ones most likely to achieve credible climate progress.